In today's video, we are going to walk through a natural language processing project from start to finish by doing sentiment analysis on Amazon reviews. Sentiment analysis is the use of natural language processing to identify the motions behind text. We are going to walk through a traditional approach to sentiment analysis using Python's natural language toolkit or NLTK, and then we will implement a more complex model called VADER that provided by Hugging Face. We'll do some analysis of how the different models perform. Hi, I'm Ria, and I'm a third year AI and data science student at Dr. Devi Patil Institute of Technology, Pimpri. I'm going to share everything we do today in a Kaggle notebook, so you can find the link in the description and copy that notebook and explore all the stuff that we will do today. Alright, let's get to the code, okay? So we are in a Kaggle notebook and you can see this is a basic outline of a setup of NLTK. What we are going to be talking about today, we are going to do some sentiment analysis in Python, and we are going to use two main techniques. The first one is the older kind of way of approaching the sentiment analysis with a model called VADER, and this uses a bag of word approach. And then we are going to look at a pre-trained model from Hugging Face, that's a type model, and this is more advanced transformer model that we are going to see how the result compare between these two models. But before we get into that, let's talk about the data and do some basic analysis with the natural language toolkit, which is a great library for Python. I am going to show you over here that we are going to use this data set, that is a bunch of Amazon fine food reviews. So these are text reviews for food on Amazon, as well as the rating that out of 5 stars that the reviewer gave them. And all of this is in CSV format that we are going to pull in. So before we get too far into it, let's do some of our inputs. We will be importing pandas as PD and import numpy as NP. For some plotting, we will import matplotlib, pyplot as PLT, and we are going to import cbon as SNS. Let's set a style sheet that we'll use for our plots, and then we are going to just to start out here input NLTK, which is that natural language toolkit we'll be using for the start. Let's go ahead and read our data. So from the input directory there is this reviews.csv, and after I read this in, I can show you here just in head command that in this dataset we have each row is that the unique ID, we have the product ID, user ID, profile name, and then the real interesting stuff. Here is the score. So this is out of 1 to 5 star ratings, how many stars the reviewer gave them gave this item, and then the text about actually this data set is quite large. There are some almost 500,000 reviews here, and just for a time sake, let's funnel it down, sample this data set. So I can do that pretty simply by just doing a head command on this and taking the first 500 rows, and then if we print the data frame shape after that, we'll see that it's 500 rows, but you could scale up this project very easily to all 500,000 products if you wanted to run a more intense analysis. Now let's go through some quick EDA just to get an idea of what this data set looks like. So we will take this score column, which we know to be a value between 1 and 5, and we are going to do a value counts on this. This gives us the number of times each score occur, and then we'll sort the index and we'll do just a bar plot of this kind. And then I set the X label as review star, and after doing a plot show, we can see here that most of the reviews are actually 5 star, but then it kind of goes down. It has a little upstick in the number of 1 star review. We have so the very biased towards positive reviews in our dataset. That's good to know before we get any further. Now the next thing we'll do is just some basic analytic stuff. Let's start by just taking one example review, the 50th value as an example, and we'll print this example. All right, so what did this person say? That he says the Oatmeal is not good, it's mushy soft, I don't like it. Quaker oats is where you go now. Okay, so seems to be a negative sentiment here, but before we get into that, let's just see some of the stuff that NLTK can do out of the box. NLTK can tokenize the sentence. So let's test this example and run NLTK word tokenizer, and all that basically does is split this into clear clean at the beginning. But then you can see that I don't and an apostrophe is split, so this is a little bit smarter than just splitting on spaces in the text, and this will give us our actual tokenized result. In natural language processing, often you need to convert the text into some format that the computer can interpret, and tokenizing, that is the way to do this. Let's just show the first 10 so we can remember what this looks like. All right, so now once we have these tokens, another thing NLTK can do out of the box is actually find the part of speech for each of this word. So let's run NLTK's post tag for part of speech tagging, and we'll run this on each of this token. Now we can see that we have each token and we also have its part of speech. So this part of speech values are codes, so you can see that um, oatmeal is NNN, and in our part of speech tagging, that means noun, a singular noun. So each of the values in this text has now been given its part of speech. So let's call this tagged, and then let's just show the first 10 again as our example. Take this tags part of speech and put them into entities. So NLTK, we can do a chunk on this. So this takes the recommended name entity chunker to chunk the given list of token. So it takes this token and actually will group them into chunks of text. Then we'll actually run entities.pprint for pretty print of this. So you can see that it's chunked this into a sentence and noted here that this is an organization. Some other interesting stuff about text that can be extracted out automatically using an NLTK. Alright, so that's just a basic premiere. Let's get into sentiment VADER model analysis. So we are going to start by using VADER, which stands for Valence Aware Dictionary and Sentiment Reasoner. So this approach essentially just takes all the words in our sentence and it has a value of either positive, negative or neutral for each of those words, and it combines up, it just does a math equation, and for all the words it will add up to tell you how positive, negative or neutral that the statement is based on all those words. Now, one thing to keep in mind is this approach does not count for relationships between words, which in human speech is really important, but at least is a good start. So we also remove something called stop words. Stop words are just words like, and the words that really don't have a positive or negative feeling to them. They are just for the structure of the sentence. All right. So let's do some sentiment analysis using this VADER approach. We are going to do from NLTK sentiment import sentiment intensity analyzer, and then we are going to also import from TQDM notebook. Import TQDM, this is just a progress bar tracker for when we are going to do some loops on this data. Then we are going to make our sentiment analyzer object by calling the sentiment intensity analyzer, creating it and calling it SIA. Now we have our sentiment intensity analyzer object. We can run this on text and see what the sentiment is based on the words. So let's run um, just on some examples. Let's say I'm so happy. We can see that this VADER approach has tagged this negative as 0. These are the scales from 0 to 1. So 0, negative, neutral 0.3 and positive 0.6, mostly positive now. There's also this compound score, which is an aggregation of negative, neutral and positive, and similarly there's one negative sentence, for example. Very interesting. Now we can run SIA on our example. So run the polarity scores on the entire data. So basically looping through this data frame, we have every text field. We want to run this and grab the polarity scores, and we can do that with a simple loop. And now we have this result of dictionary with each id, the negative, neutral, positive and compound score of each. But we want to store this into a pandas data frame because that's easier to work with. Let's do that really quickly by just running pd.data frame on this dictionary. Pandas can take in a dictionary pretty easily, except for its oriented the wrong way. So now basically we have our data frame but with our scores, and we also have all the other values from our original data set including the text. So if I run ahead on this, we can see we have a sentiment score and a metadata. Alright, if this is in general, is in line with what we expect, so we are gonna make some assumptions here about our data, that if the score of the item that the reviewer gave it is a 5-star review, it's probably going to be more positive of text than if it was a score of 1-star review, is going to have more negative connotations that than a 5-star review. And we can do that by just doing a simple bar plot. So let's use cmon. We are going to do a bar plot of this data where our data is VADERs. So we can see 1-star review has a lower compound score and a 5-star review is higher, and it's actually exactly what we would expect. Looking at the compound score, we can look at the positive, neutral and negative scores for each. So we are going to do that by doing something like SNS bar plot. The positivity is higher as the score is higher in terms of star. The neutral is kind of flat, and the negative goes down. Great. This just confirms what we would hope to see and shows that VADER is valuable. In having this connection between scores of the text and the sentiment scores, and that it does relate to the actual rating review of the reviewers. Alright, so now we are going to take it up a notch. Roboto model. Our previous model just looked at each word in the sentence or in the review and scored each word individually. But like we mentioned before, human language depends a lot on context. So if I say something up, we'll see a sentence that could have a negative word actually, could be sarcastic or related to other words in which why it makes it a positive statement. So this VADER model wouldn't pick up on that sort of relationship between words. But more and more recently, these transformer based deep learning models have become very popular because they can pick up on that context. So we are going to use from Hugging Faces, which is one of the leader in this type of models, and gathering them and making them easily available. We are going to import from transformers now. This is Hugging Faces library. You could pip install transformer to get this on your local machine, or of course you can just run it in a Kaggle notebook like we are right now. So let's make sure this works from transformers. We are gonna import our auto tokenizer, and now this is gonna tokenize similar to what we showed Analytica can do. And then from transformers we are gonna import auto model for sequence classification. You can see that there are a lot of different types of model that Hugging Faces has. And then we are also going to import from SciPy special softmax, which we will apply to the outputs because they don't have softmax applied, and this will smooth out between 0 and 1. And then we run the auto tokenizer in the auto model sequence classification method and load it from a pre-trained model. It will pull down the model weights that have been stored, and this is really great because this model was trained on a bunch of Twitter comments that were labeled, and we don't have to retrain the model at all. We can just use this trained weights and apply it to our data set and see what comes out. So anytime you do this, the first time you will see that it needs to download all the weights which is expected. And now we have a model and a tokenizer that we can apply to the text. So let's here we again use our example that we used in the start. On using the Robota model that we have pulled First thing is encoding the text. So we are going to take our tokenizer that we pulled in. Let's go ahead and run this on the entire dataset like we did before with the VADER model. Pretty easily by just making a function out of the code that we did before called polarity scores roberta, where it takes an example like our code did before and it runs all of this and just returns scores dictionary. So now we could run this on one example of text and get the score dictionary like we had written code for above. And we are going to enter iterate over the data set just like we did before. All right, it did break on one of this example because the text had some issues with it and it wasn't able to run through the roberta model. So instead of debugging this all right now, and it has to do with the size of the text itself. There's a certain size of text that's just too big for the model to handle. We will skip those and we'll keep those by adding a try except clause here. So it will run through except for when this runtime error occurs. In that case, we will just print out a message. So we can know that it broke for ID this and let it go through all 500. Now let's actually take the result of this and make the result dictionary similar to what we did before. So this line of code which makes this result run on the transformers on it, and let's call this result data frame and it will merge back on the main data set. Now if I do a head command on this, we can see now we have our VADER scores, all four of them, and our Trobata scores for each row in the data set really quickly. Let's come compare scores across our across or between models, and we can do this using Seaborn's pair compare result. But one thing that we notice here is the 5-star reviews are this purplish color, and if we look at VADER, the positive reviews are more so to the right on for this 5-star reviews for the roberta model. You can see it's a way over to the right, and then we can see that there are some correlations between roberta model and the VADER model. It's a little hard to see exactly if there are correlations here, but one thing that becomes very clear is that the VADER model is a little bit less confident in all its prediction compared to the roberta model, which really separates the positivity and neutral and negative scores for each of these predicted values. So that's it for our sentiment analysis project. So there we have it. We walked through two different types of models that you can use for sentiment analysis. Explore some of the differences between them. We actually ran it on a whole corpus of 500 data, different reviews from Amazon. You could scale this up and run it on all 500,000 examples and see what insights you can find. So thanks again for watching my video, and I'll see you in the next one.